Okay, once again, you are welcome to learn engineering drawing from me again. Our attention for this video is going to be on polygons. We are still on um revision on this scheme of work, the semester's work. Understand? One of the topic you guys did this semester, it's on polygons. So we learned that polygon is a plane figure bounded by five or more than five sides, right? And also angles, which means that the moment you add a side to an already existing polygon, it gives you a new polygon. So we also made reference to hexagon as being the most common polygon you can be asked to construct in an exam or test. So I will be teaching you guys how to construct it. And mind you, we have two major ways of constructing. We have across flat and across corners. Then we also have the general method, and we are going to be doing all of them one after the other. So starting from construction of polygon across um, corners and flats. Okay, before that, let me just explain what they mean by across flat and across corners. So I'm having a polygon. You'll be given distance across flat. Across flat means the diameter of a circle, right? So when you hear across corners, it means that the polygon will be formed inside the circle. Inside the circle. Mind you, you'll be given the distance across flat or distance across corners. This is what they mean. It means the diameter of the circle from one circumference of the circle passing through the center of the circle, meeting at the other circumference at the other end. You understand? So when you hear across flat, this across corners. Across corners. When you now hear across flat, this is what they mean by across flat. You will be given distance across flat as usual. That's the diameter. Across flat means it's going to be constructed on top of the circle. You understand? On top of the circle. So that's what across flat is. This one is across corners. So you need to take note of that. So okay, we're asked to construct a polygon whose distance across corners is let's say distance across corners they gave us to be 10 centimeter. So we're now asked to construct the polygon. So we'll draw a straight line. After I draw a straight line, since they say distance across corners is 10, and I explained earlier that when you hear distance across corners, they're talking about the diameter, and we want to draw a circle, so we need a radius. That's half of the distance across corners. Since they say it's 10, so we are making use of 5. So I'm drawing. After drawing this, the reason why they normally use hexagon among every other polygon is because it's easy to construct since it's of a special angle, that's angle 60. That means that the radius of the circle drawn can be used to strike an arc, placing it at this part of the circle, strike at the top and strike at the bottom. Come over to strike at the top and strike at the bottom. Come over to this other side, strike at the top and at the bottom. So once you have gotten those lines, you just have to draw straight lines to get to each of the points. Like this. So you're just connecting the point at the circumference. So as simple as this. So when you hear construct a polygon whose distance across corners is blah blah blah, whatever value it is, you just have to take that value to be your diameter, divide by 2 to get your radius, use it to draw a circle. The radius of the circle, place it at this end, strike at the top and at the bottom, come over to the other end, strike at the top and at the bottom. From there, connect the point at the circumference of the circle and you have gotten it. So let's say you were asked to construct a polygon whose distance across flats is 8 centimeter. It's still simple, but this one requires a different approach, but like I said, it's still simple. So let's construct it at this part. Okay, how do we go about that? Still the same process. At the start, draw a fence line. So I've drawn my fence line. So there, get your distance across corners. They say distance across corners is 8. So from there, get your radius. Radius should be 4. Use it to draw your circle, a complete circle. Placing it like this. Then you draw. After drawing it, just as distance across corners rather, you repeat the same process to get your point at the circumference. Still the same thing, but this is the catch. This is the only difference. You connect the point at the circumference to the center of the circle. Point at the circumference to the center of the circle. Can project it out a bit. Repeat the same process here. Okay, so once you are done with this, the next thing you need to do is to draw a perpendicular line at the circumference. Wherever you're having a line at the circumference, draw a perpendicular line against that slanted line. So what I teach my students is this: balance your 8 and 10 to draw a perpendicular line. So I'm balancing the 8 and 10 like this. These parts, sorry, this one and this one, I'll balance. If I want to draw a vertical line, I'll balance it in such a way that it will stay straight to the horizontal, then I'll draw my vertical. If I want to draw a horizontal, I'll balance it at the vertical, then draw horizontal line. It's just the reverse scenarios. So I'll balance it like this. I'm drawing a straight line. Come over to this side, do the same. Do the same here. Now you can also use your 45-degree set square. That's your choice. 45-degree set square, meaning you balance it like this. Whichever one that suits you. Once you balance it like this, you just project it out. You understand? But I recommend this for my students. Okay, come over to this side, repeat the same process, 8 and 10. Come to this side, 8 and 10. This side also. 8 and 10. With this, the point of intersection between those perpendicular lines, you connect them together to get the sides of the polygon of this hexagon. Like this. And this is it. Distance across flats. This is a construction. Why this is a construction of hexagon across corners. We need to learn how to construct the general method, right? General method of constructing polygons. So let's say we are asked to construct a polygon whose side, the length of the side is 6 centimeter. So this is what we will do. We draw a straight line first. They say the length is 6, right? No issue. So I'll measure 6. After measuring 6, I will balance 8 and 10 here, or use your set square to get your perpendicular line. Project it up. Do the same thing here too. Project it up. After doing that, measure 6 at this place. Come here, measure 6 too. If you notice, you realize that we got a box. There are some questions that will ask you to construct a box, and the first, let's say first 3 or first 4 polygons have starting from the same base, or having the same base, or drawn on the same base or the same plane. So what you have done now, you just outline these parts. Okay, we'll come to that towards the end of this one. So from there, you draw, let's label. We'll say here is A, here is B, here is C, and here is D. So this is what I'll do. From here to this place, I'll draw a line to this side. Use my compass. Place at B. Open it to A. Draw to meet D. After doing this, I'll get the middle. The middle is going to be 3, obviously, right? I'll come here, measure 3. Then I'll draw. Now after doing that, this place automatically becomes my point 4. That's the center of the square, which is having 4 sides. Why this part becomes my point 6. And what polygon have 6? That's hexagon, right? So if we're asked to construct hexagon, we'll open our compass at this side. We'll open our compass at this side. Then turn, starting from A, open it wide to A. From point 6, open it to A, down to B. Now after doing it, they say the length is what? The length of the side is 6, and 6 is AB. So I'll measure AB instead of going to my ruler again. Just measure AB. Strike 1. Come here. Strike another one. 1. Come here. 1. This side. Repeat the same process. 1. If you place it here, it automatically meets this one. but I'm not doing that. So I'll outline, come to this side. This is my second side. So I have 3, I have 4, I have 5, then this part 6. So this is my hexagon. So let's say we were asked to construct a pentagon. How do we do it? If it's pentagon you were asked to construct, there's no need doing this one. If we have 4 here and we have 6, that simply means that the middle of this from here to here automatically um the middle from here to here automatically becomes a 5, abi. That's for pentagon. And for us to get the middle, you just have to measure to check. You can actually bisect, but I don't usually recommend bisecting. So many construction automatically cause increase in rates of error or chances of error. So I'm having 2.2. 2.2 divided by 2 is equal to 1.1. So I'll locate 1.1 and this is 1.1. So automatically here becomes my 0.5. Here automatically becomes my 0.5. And what do I do? Just as I showed you guys for the hexagon, I don't want to repeat this whole stuff. That is why I'm just using the same diagram. So I'll open my compass from 0.5 to A. I need to draw a circle. I'll draw a circle. After drawing the circle, they say the length is 6, abi. That's A to B is 6. Hope you have not forgotten. So I'll strike 1 here, come to this side. Strike 1 here, come here, leads me to this top. Come here, leads me to this top also. So there's no need drawing another one since they are of the same point. So I just have to draw a straight line to this place, draw a straight line to this place, this one here, this place to this place. So this is for pentagon and this is hexagon. What if you ask to construct heptagon or octagon or even decagon? It's simple. If from here to here, if here is 4, 5, 6 and the distance between the both of them or each of them are the same, that means that distance between 6 and 7 will be equal to 5 and 6. And remember, we got the distance between these other ones as 1.1. So I just have to measure 1.1 upward. 1.1. So this is 1.1 and this is also 1.1. So this is for number 7 and this is also for number 8. 7 and number 8. So it's still the same process. For number 7, put it here. Open your compass to A. Then you draw. After drawing, A to B is the length that you were asked to use. So I strike 1, 2. Come over to this place. 1, 2. This one gets to here. This one too gets to this place. So again, there's no need drawing that part. So I just have to connect. So when I connect this, I'm having this to this. I'm having this to this. right? So let's say again I want to do for 8. It's still the same process, but I'm tired. It just goes on and on and on down till we have pentagon, hexagon, heptagon, octagon, nonagon, decagon, decagon, dodecagon, tridecagon, tetradas, and so on and so forth. The moment you add one more side to it, it changes the name, abi, and becomes a new polygon. So these are just what you need to know about polygons.